Okay, without graphing, what is the y-intercept of this function? So they gave you a table of values, x values and y values. Can anybody identify the y-intercept from the table? What is the definition of a y-intercept? What did you say? Right, where it goes through the y-axis. So which one of these points would sit on the y-axis? If you go 4, -2, that means you go over 4 on the x-axis, down 2 on the y-axis. Is that going to sit directly on the y-axis? No. Now, I don't know, I know y'all don't talk really in this class, so I don't really know if you just don't get it or if you just don't want to say it. So even though it told us not to, I am going to graph it so that you'll understand. 4, -2 means you would go right 4, down 2. So that point would sit here. Is that a y-intercept? No. 2, -1 means you would go right 2, down 1. Is that a y-intercept? No, it's not on the y-axis either. 0, 0 means you wouldn't go left or right. It's at the origin. Is that a y-intercept? Yes, isn't that point sitting directly on the y-axis and the x-axis? So technically it's both. It's the y-intercept and the x-intercept. So 0, 0 is the y-intercept. Anytime you're looking for a y-intercept, you look for where x equals 0. Because if x is 0, that means you didn't go right or left and you're still sitting somewhere on the y-axis. In this case, you also don't go up or down, so you're sitting at the origin. Does that make sense? So anytime they ask for a y-intercept, you're looking for what? Where x is 0. Because if you don't go left or right at all, then you're sitting on the y-axis and you're a y-intercept. Okay. Today we are going to continue working in our interactive notebook, so go ahead and get those out. Okay, does everybody have Essential Question 4 copied? Okay, so today we're going to learn how to add, subtract, and multiply radical expressions. Now, that's going to be on pages 27 and 28. So I want you to go ahead and glue down those pages that you were just given on 27 and 28. All right, so first we're going to learn how to add and subtract radicals. When you are asked to add or subtract radical expressions, you can only combine like radicals. Okay, you can only combine like radicals. Okay, and like radicals have the same index. So like they're both a square root or they're both a cube root, which means they have the same index. And they have to have the same radicand, which is that number on the inside of the radical symbol. Okay, so like radicals means they have the same index, like they're both a square root or they're both a cube root or both a fourth root. And they also have to have the same radicand, the number on the inside. Now, to add or subtract radicals, you need to simplify everything first. running out of room. I'm just going to have to write it like this because I ran out of room. Simplify everything first. Okay, which is what we learned the last 2 class periods that we were doing this. To combine them, to combine like radicals, you will add or sometimes subtract the coefficients, which are the big numbers on the outside, not the index, but the big numbers. And they don't have to match. Just the index and the radicand have to match, but the coefficients do not. And you keep the same radicand. Okay, so now let's try some examples of adding and subtracting radicals. All right, what did it tell us we need to do first? Guys, simplify everything first. Now, the reason we need to do that is because right now, okay, we see that both of them are the square root of something. This is 2 square roots of 45. This is 2 square roots of 5. So they have the same index. They both have a little understood 2 up here. And they don't have the same radicand. This one has a radicand of 45. This one has a radicand of 5. So currently, we're not able to subtract them because they don't have matching radicands. That's why you simplify everything first. So 45 can be factored 9 times 5. And then 9 will become 3 times 3. And then 5 is prime, so it just drops down. I'm going to try to make it a little bit bigger. Hold on. Okay, so now all 3 of these factors are prime, which means we're done with our factor tree. So we circle, kill, and kick out. Circle our 3's. Kill 1, kick 1 out. 5 was not circled, so it goes back in the house. And then to simplify 2 square roots of 45, what else needs to be done? Right, this 2 will now join with the 3 that's also been kicked out, and they will multiply together to make 6 square roots of 5. Okay, so 2 square roots of 45, we just simplified, and it became 6 square roots of 5. So this is no longer there. It's been simplified to this. Now 5 is prime, so you can't factor tree it. This one's already in simplest form. So you just bring down the minus and then the 2 square roots of 5. So now their indexes still matched. They're still both a square root of something, and they're both square roots of 5, which means they also have matching radicands. So what does it say to do? I just realized the video wasn't going. So let's type it in our calculators together. Type in the question. So type in 2 square roots of 45. Arrow over so that you come out from under the radical. Then press minus 2 square roots of 5. And then when you hit enter, what do you see on your screen? Okay, when you type in this question, 2 square roots of 45 minus 2 square roots of 5 and hit enter, what do you see? Come on, anybody? 8.94, right? Now type in our answer, 4 square roots of 5. What do you see? 8.94, same thing, which means we did it right. We're not actually changing the value of anything, we're just simplifying it, so it should still be the same value, we're just putting it in simplest form. Let's try this second example. This time they're asking us to combine 3 different radicals. Now, so far they all have the index. if there's no index visible, isn't it understood 2 right here, and right here? So all of them have an index of 2. They're all square roots, so they match in that sense. But do all of their radicands match? No. We have a radicand of 12, a radicand of 3, and a radicand of 20. That's why up there on that page it says simplify everything first. What radicals can be simplified in this case? Which ones can be simplified? 20 and 12. So let's start with 12. What are some numbers that multiply to make 12? 3 and 4. And then 3 is prime, so it just drops. 4 can be broken down into 2 times 2. Now we are ready to circle, kill, and kick out because all 3 of those are prime. So circle up the 2's, kill 1, kick 1 out. 3 gets to still live in the house. And then what do? Multiply it by the negative 3 on the outside. And so the final answer becomes negative 6 square roots of 3, correct? All right, now we move to plus 3 square roots of 3. Can this one be simplified at all? No, 3 is already prime, so if you tried to factor tree, it would just be 3 times 1. So just bring it down, plus 3 square roots of 3. And now for the 20, we can try to factor tree it because what numbers multiply to give you 20? Right? And then 5's prime, so it just drops. 4 becomes 2 times 2. Okay, now all 3 of those numbers are prime, so we're ready to circle, kill, kick out. 5 gets to still be in the house. And then don't forget about this 3 on the outside that will now come down and multiply by that 2 to make 6 square roots of 5. And then remember this was a plus, so it just comes down. Okay, so now when we go to actually try to combine them, we can only combine 2 of them because these 2 match. They're both square roots of 3. So you would do negative 6 plus 3, and that's negative 3 square roots of 3. But then this one is not a like term. It would just be kind of like if this were negative 6x plus 3x plus 6y, you wouldn't be able to do anything with this one. It would just stay like that. Now, just like always, you can check on your calculator. So first type in the original question, negative 3 square roots of 12. Make sure you use the arrow to arrow over and out of the radical before typing in plus 3 square roots of 3. And then arrow over again to get out from under the radical. And then plus 3 square roots of 20. And what is that equal to? 8.22. Now let's type in our answer, that negative 3 square roots of 3, arrow over, plus 6 square roots of 5 equals 8.22 as well. So that's how you know you have the correct answer, because when you typed them both in your calculator, they matched. Okay, now before we move on to multiplying, we're going to practice some adding and subtracting. So we're coming back to this though today, so don't put your notebook away, just close it and put it to the side. Now go to page 20 in your unit packet, page 20. All right, number 1, they want us to add the square root of 6 to the square root of 6. Can they be added? Yes, they have matching indexes and matching radicands. They're both an understood 2 in the index place, so that matches, and then they both have a 6 in the radicand place. So what is the square root of 6 plus the square root of 6? Okay, well, let me just, well, I erased it already. Like, okay, look, on the outside of this square root of 5 is a 2. On the outside of this square root of 5 is a 3. What do you think is understood to be right here? A 1. Okay, and same thing with this one. So since they're both square root of 6, that's their like term. And then 1 plus 1 is 2. Okay, and then I feel like y'all know how to check them now, so we're not going to check every one of them. That way we don't use all our time on this. But if it's a test, you better check your work, okay? All right, number 3. Can these be subtracted? Are they matching radicals? Yes, they're both square roots of 5, so that's their like term. And now you just subtract the coefficients. 2 minus 3 is -1. Now you can write -1, but on the test, it's just going to have a negative. The 1 is understood. Okay, like if it's a multiple choice question, you wouldn't see the 1, you would just see the negative sign. All right, number 5, are those matching radicals? Yes, they're both square roots of 3. So you just combine the coefficients. What's -2 minus 2? -4. Okay, now we get to some where we have to do a little bit of work because right now, do they match? No, so that's why it said simplify everything first. Now, I'm going to need to make myself some scratch paper to have room to do factor trees, so you might want to get out notebook paper unless you can write super small. Okay, starting with the square root of 20. It can be simplified. What numbers multiply to 20? Right? And then 4 will break down into 2 times 2, and then 5's prime, so it just drops. So now that they're all prime, we are ready to circle, kill a 2, kick out a 2, and 5 gets to stay inside. So now this one has been simplified. And now we try to simplify 45. What numbers multiply to make it? What are 2 numbers that multiply to 45? 9 and 5. And then 9 becomes 3 and 3. 5 is prime, so it just drops down. Now that they're all prime, we circle the 3's because there's 2 of them. Kill 1, kick 1 out, and the 5 gets to go back inside. And now remember, they're wanting you to add these. Are they able to be added now? Yes, they're both square roots of 5. That's their like term. And 2 plus 3 is 5. Okay, and if you did type in the square root of 20 plus the square root of 45, you would get the same decimal value as when you type in 5 square roots of 5. Okay, does everybody have it copied? Not yet. Okay, number 9. Okay, square root of 3. Can we simplify it? No, 3 is a prime number, so there's nothing that can be done. What about 27? It would be 9 times 3, then 9 would break down into another set of 3's, and then this 3 would drop. So now you circle any sets of 2, and we only have one set of 3's. So 1 gets killed, 1 gets kicked out, and then that one goes back inside. And then this one could not be simplified, so it just drops down as well as the plus. And so now what's the answer? Good. 4 square roots of 3. Do y'all all know where he got the 4 from? Correct. There's an understood 1 on this one, and 1 plus 3 is 4. Everybody got it copied? All right, number 11. 2 square roots of 20 plus 2 square roots of 45. Can they currently be added as they are? No. So we need to simplify them, and they both can be simplified. 20 can be 5 times 4, and then 5 times 2 times 2. And then you circle, kill, and kick out. So circle the pair of 2s, kill one, kick one out, put the 5 back in. Don't forget about this 2 that was already outside the house that will now join with that one to make 4 square roots of 5. So now we're done with this one. We've simplified it to 4 square roots of 5. Now we need to simplify 2 square roots of 45. That's 9 times 5, which is 3 times 3 times 5. Circle the 3s, kill one, kick one out. 5 gets to go back in. And then don't forget about that 2 that will drop down and make the 3 become a 6. Okay, now they're asking you to do what with these 2? Add them. So bring down the plus sign, and now they match because they're both square root of 5. And how many square roots of 5 are there? 10, because 4 plus 6 is 10. Are you talking about for this class? Next Friday. Tomorrow I'm going to teach the last topic. I'm going to give you the review sheet to take home over the break. Now, it's not required that you do it, but it's highly recommended. And then Thursday after the break, we'll go over it, and Friday's the test. So you really should try to work on it through the break, because that's kind of a big gap of time to not see this and then come back and test Friday. But that's the only way we could do it. There's no way I could get the test in by tomorrow. We weren't ready yet. All right, number 13. They want you to add them. Can they currently be added as they are? No. Why not? What? 2 different radicands, right? One's a radicand of 8, one's a radicand of 2. Well, 2 is simplified. You can't simplify that any further, but 8 can be simplified. 4 times 2, and then 2 times 2, and then drop that 2. So now that we have all prime numbers, we will circle up any sets, kill one, kick one out, put the ones not circled back in the house. Don't forget about anything that was already outside the house that will now join the newly kicked out person, making 6 square roots of 2 on the outside. And so now that one has been simplified to 6 square roots of 2. Now bring down the plus 3 square roots of 2, and now can they be added? Yes, because now they're both square root of 2, that's their like term, and you add the coefficients, which gives you 9. Okay, copy that, and then we'll do 15. Okay, everybody got it copied? All right, number 15. Can they currently be subtracted? Yes, they're already both square root of 5. So all you have to do is 3 minus 2 is 1. And you can write the 1, but on the test, it would just look like this. The 1 is understood. All right, number 17. This time they're asking you to add together 3 radicals. Can they currently all 3 be added? No. Can any of them be simplified? Which one? The 24. These two cannot, because think about it. If you tried the factor tree of 6, it would just give you 2 times 3. And there's nothing to circle, right? So even though 6 is not a prime number, it also can't be simplified any further. But the 24 can be. What numbers multiply to give you 24? Okay. And then 6 becomes a 2 and a 3. 4 becomes a 2 and a 2. Now all of those are prime numbers, so we're ready to circle any pairs, kill one, kick one out. Anything not circled goes back in the house and multiplies together if there's more than one. So what do we have inside the house? 6. So now look, we've got square root of 6 plus square root of 6 plus 2 square roots of 6. Now all 3 of them are square root of 6. They all have like terms. How many square roots of 6 are sitting there? 4, right. Because both of these have an understood 1. 1 plus 1 plus 2 is 4. Okay, now let's look at number 19. Okay, 19, we got 3 radicals. Can they currently be combined? No. Okay, which ones can be simplified? The 27. So, what are the factors of 27? 9 times 3, and then the 9 will become a 3 times 3, and then you'll bring down that 3. Now we circle, kill, and kick out. So we have a pair of 3s, kill one, kick one out, put the other one back inside. Then don't forget that, look up here. This is an understood -1 that was already outside. And when you multiply it by 3, you now have -3 square roots of 3. Okay, and then this one, we just finished factor treeing it, and didn't we get 3 square roots of 3 out of it? But then don't forget, there's a 3 already on the outside that will now join with it to make a 9 square roots of 3. And then there's a plus between those, so you just bring down the plus, and now bring down the -2 square roots of 3, because it cannot be simplified any further. Now they all are like radicals. They all have the same index of 2, and they all have the radicand of 3. So now you just combine the outside numbers, which are called the coefficients. -3 plus 9 is 6, and then -2 would make it 4. Okay? And on the test, make sure once you get that answer, you type this in the calculator, see what decimal it is, type this in, make sure it matches. Okay, for the next 10 minutes, I'm going to let you work on the evens by yourself. Okay, and then after 10 minutes is up, we're going to move on to multiplying radicals. Okay, before we move on, are there any on the even side of this page that you want me to go over? 18 to 20? Okay. All right, number 18. They're wanting you to add and subtract with these radicals. But to add or subtract, you need to have them matching. Okay, well currently they don't match, but there are 2 of them that can be simplified by factor tree. 45 is 9 times 5. 9 is 3 times 3. And then 5 is prime, so it just drops. You circle the pair of 3s, kill one, kick one out, put the 5 back in the radical. Don't forget about this -1 that will now come down and multiply by that 3 to make it -3 square roots of 5. So now we're good with that one. This one can't be simplified, so you just drop it down. And now we're going to simplify this one. 9 times 6 is 54. 3 times 3 is 9. 3 times 2 is 6. Now that they're all prime, we only have one set of 3s that can be circled. You kill one and you kick one out. 3 and 2 get to go back inside, so they multiply together on the inside to make 6. Don't forget, this is also like a -1. It's -3, so you can just basically bring it down, and it's the same thing as multiplying it by negative square roots of 6. So now, these two match, right? But this one does not. So it's just going to stay what it is. And then you're going to do 2 minus 3 is -1 square roots of 6. Now, if you ever work a problem like that and you feel like, why didn't they all come out matching? It's okay. Sometimes they don't. And that's when it's a good idea to type in the question and check. So let's do that together. First, type in the question, negative square roots of 45. And then arrow over to come out from under the radical before typing in plus 2 square roots of 6. Arrow over, and then minus square root of 54. And what do you get? Okay, negative 9.15. And so if we're going to stop at the second place, the hundredths place, we need to round it to 1/6, right? Because the next number is 7. Okay, now let's type in our answer. -3 square roots of 5, arrow over, minus the square root of 6, and you get right. So that lets you know you did it right. Okay, that's how you can always check to make sure you did it right. All right, now you said number 20 as well? Okay, number 20. Okay, this time they're wanting you to combine 4 radicals. Well, these two match, but these two do not, and all 4 of them can be simplified. So this is quite a bit of work in this one problem. Well, thankfully these match, so that's like really only simplifying 3. 6 times 4, 2 times 3, and 2 times 2. You would circle your set of 2's, kill one, kick one out. The 2 and the 3 get to go back on the inside, and they multiply together to become 6. So that one's done. Now that one's the same thing, so it's also going to be a 2 square roots of 6, and we bring down the plus sign in between them. Okay, now square root of 20, we need to factor tree. 5 times 4, and then that would be 5 times 2 times 2. So we circle, kill a 2, kick out a 2, put the 5 back in, bring down the plus, and then we factor tree 54, which would be 9 times 6, and then 3 times 3 times 3 times 2. We can circle the 3's, kill one, kick one out, and then 3 and 2 get to go back on the inside and make 6, and then bring down the plus. So now that we've simplified, 3 of them are like terms. How many square roots of 6 are there? How many square roots of 6 are there? 2 plus 2 plus 3, 7. And then the 2, this square root of 5 doesn't match it, so you just write it separately. So 7 square roots of 6 plus 2 square roots of 5. Now, if you wrote your answer 2 square roots of 5 plus 7 square roots of 6, that's completely fine. Same thing. Okay, did anybody have any other questions? Okay, and the reason it's okay to write them in any order like that is because addition is an operation that is commutative. Like, isn't 2 plus 3 the same exact thing as 3 plus 2? That's what commutative property means. It means you can add in any order because you're going to get the same answer at the end anyway. What other operation is commutative besides addition? Multiplication. 2 times 3 is 6. 3 times 2 is 6. What operations are not commutative? Subtraction and division. Think about it. If you have like 2 minus 3, that is not the same thing as 3 minus 2. This one is -1, this one's +1. Subtraction is not commutative. Neither is division. If you do 2 divided by 3, that's like 0.67. If you do 3 divided by 2, it's 1.5. Okay, so you don't get the same answers when you switch them around with those two operations, so they're not commutative property. Addition and multiplication, though, are, because it doesn't matter what order you do them in, you get the same answer anyway, right? Okay, now let's move on to multiplying. So go back to your interactive notebook and go over to page 27. And then don't forget, if you haven't already, both of these are Unit 1A, so you can title the top of these pages Unit 1A and then make sure you've numbered them. And now we're going to talk about multiplying radicals. Alright, whenever it comes to multiplying radicals, we can multiply them if they have the same index. So kind of like adding and subtracting, but a little bit easier, because with adding and subtracting them, they had to have the same index and the same radicand. Whereas with multiplying, they just have to have the same index. It doesn't matter about their radicand. So in my opinion, multiplying is a little bit easier because you just basically multiply the outside numbers together and the inside numbers together and then simplify. So step 1, multiply the numbers outside the radical. Okay, so that's what you'll do first, is you'll multiply the numbers on the outside of the radical. And what are those numbers called? Starts with a C. Coefficients. So you'll multiply the coefficients together. Then after you've multiplied the coefficients together, you multiply the inside numbers, which are called the radicands. Okay, and remember, you're only able to actually do these steps if their index matches. So like if you have a square root and a cube root, you can't multiply that. But if you have a square root and a square root, you can multiply, or if you have a cube root and a cube root, you can multiply. And then step 3, once you've done all the multiplying, you will simplify. So unlike adding and subtracting, you don't simplify till the end here, where with other adding and subtracting, you simplified first. Okay, so now let's try some examples. Okay, for this first example, what are the outside numbers, the coefficients? Correct, each of them has an understood 1. So 1 times 1 is 1, not that you have to write it. Now we multiply the inside numbers. What's 3 times 3? 9. So really, like I said, you don't have to write the outside 1. So really, we just have the square root of 9, and then you simplify it. What's the square root of 9? It's not a trick question. What's the square root of 9? 3. That one was easy to simplify because 9 is a perfect square. Okay, now let's stop for a second and talk about a little side lesson. The reason that the square root of 3 times the square root of 3 just equals 3 is what I'm about to show you. Okay, it's the same thing for like the square root of 4 times the square root of 4 will just equal 4. And now let's talk about why. Say you have x plus 5 equals 10. What is the inverse operation of plus? Right, you would minus this 5 on both sides, correct? Because the goal is to cancel it out, and plus 5 minus 5 is 0, so it cancels. So the inverse operation of addition is subtraction. What if you have 5 times x equals 10? How do you cancel out multiplication? Division. That's the inverse operation of multiplication, because 5 divided by 5 is 1, so they cancel out. So we know what inverse operations are. What you probably have never learned is that the inverse operation of a square root is squared. Like if you have the square root of x and then you square it, those two things cancel each other out, just leaving the x. Okay, those are inverse operations. The square root and the squared are inverse operations. So are the cube root and the power of 3. Those would cancel each other out. So what is x times x? What's x times x? X squared, right? And y times y is y squared. So what would the square root of 3 times the square root of 3 be? If x times x is x squared and y times y is y squared, what would the square root of 3 times the square root of 3 be? The square root of 3 squared, right? Well, didn't we just say that these two things are inverse operations and they cancel each other out, which is why you're only left with a 3. Okay, so look at this. The square root of 4 times the square root of 4 is literally the square root of 4 squared, because there's 2 of them. Well, those cancel each other out, which is why you're only left with a 4. Does that make sense? Why you just get back the number when they match like that? Okay, so now let's continue the second example. Okay, this time, remember, step 1, multiply the numbers outside the radicals. What would that be for this one? 8. 2 times 4 is 8. Now we multiply the numbers inside the radicals. So 12 times 15 is 180. Okay, so now we've done steps 1 and step 2, and now we do step 3, which is to simplify. So we can simplify 180 by finding two numbers that multiply to 180. What? Very good. You shouldn't have trouble figuring out two numbers that multiply to make it, right? Because you literally just multiplied those numbers together to get it. Now, you don't have to use those numbers if you can think of other numbers that make 180, but obviously those would be the easiest ones to use. And then 12 breaks down into 4 and 3. And then 15 breaks down into 3 and 5. And then 4 will break down once more into 2 times 2. And then we drop the primes. So we have 2, 2, 3, 3, and 5. Now I'm going to circle pairs. We have a pair of 2s and a pair of 3s. The only thing not circled was the 5, so it gets to remain inside the house, up under the radical. Of the circled ones, one of each gets killed and one of each gets kicked out. Well, if you have a 2 and a 3 on the outside, they multiply together and become a 6. And so that, oh, but is that the final answer? So what did I forget to do? Right, and that really, I didn't do that. Like I really made an accident, or I really had an accident there, whatever I'm trying to say. So that's why it's so important for you to check these, like on your test, type in the question, type in your answer, because you can see that when you're going fast, even I just made a mistake and forgot the 8. So you need to make sure you always check your answers, because if I had have been on a test and gone to my calculator and typed in that and typed in 6 square roots of 5, I would have immediately known something was wrong, and then it would have hit me, oh yeah, there's an 8. Okay, it's very important you check your answers. Okay, now let's look at example 3. With example 3, we have a square root of 3 on the outside of parentheses. What do we have to do here? What property do we have to do? Right, distribute. And distributing is multiplying. So you're multiplying the square root of 3 times 3. Well, when you do that, one of them's an outside number, a coefficient, and the other one's an inside number, a radicand. So you don't actually multiply them together, you just do this. You just smash them together like that. Put the coefficient on the outside, keep the radicand on the inside. But now when we go to distribute the square root of 3 times the square root of 6, they are both inside numbers. So you can actually multiply those and it becomes 18. Now don't forget there's a plus sign, so you bring it down. Okay, so now we've turned this from a multiplication problem into an addition problem when we brought that plus down. So now what do you think we need to do? Simplify. Which one can be simplified? Right. What numbers multiply to give you 18? Okay. And then 6 becomes a 3 and a 2. We drop this 3 because it's prime. We can now circle the pair of 3s, kill one, kick one out, put the 2 back inside. There was no outside number already there, so this one's good. Will it add, though, with this 3 square roots of 3? Will those combine? No, because they're not like terms. One's a square root of 3, one's a square root of 2, so that's your final answer. You can't actually combine them. Okay, any questions so far? All right, now let's try this last one. Okay, so I'm pretty confident you all know how to distribute. That's something you learned in middle school. Okay, you're just multiplying the outside thing times both inside things, one at a time. Well, over here in this fourth example, we're going to distribute, but it's double distribute. Now, I'm not sure how much of this you learned in middle school, but if you learned it in middle school, it's called FOIL. Your teacher may have called it FOIL, for first, outer, inner, last. And sometimes I teach it that way, but honestly, sometimes I just feel like it's easier to call it double distribution, because you all know how to distribute. So we're going to start with this guy right here and distribute the 3 to that one and to that one. Okay, just like we did in the previous problem, but this time there's 2 things to distribute. So when you distribute this 3 to this 3, what do you get? 9, right, because remember, distribution is multiplication. Now when you distribute the 3 to this negative 4 square roots of 3, you can multiply the outside number, so 3 times negative 4 is negative 12, but then the square root of 3 will just stay like that because there's nothing to multiply it by in that scenario. Okay, so see how all I've done so far is distributed this 3 times this entire thing, and I got this? Well, now this is why it's called double distribution, because I'm going to distribute a second time. I'm going to do this one to both of them. Okay, what is the square root of 3 times 3 going to become? Can they actually multiply together? No, because one's a radicand, one's a coefficient, so you just do them like this. Just mash them together. Kind of like if you were doing x and 3, you would just put 3x. Now we have to distribute the square root of 3 times negative 4 square roots of 3. Well, this is an understood 1, so that 1 times the negative 4 is negative 4. And then what's the square root of 3 times the square root of 3? Isn't it the square root of 9? Which in a second will really just be a 3. Okay, so now I can go ahead and combine these two because they're matching radicals. They're both square roots of 3. And negative 12 plus 3 is negative 9. Now, as far as these two are concerned, what's the square root of 9? 3. And then it's touching the negative 4, so wouldn't that just become a negative 12? Because negative 4 times 3 is negative 12. And what's 9 minus 12? Negative 3, right? And so that would be the final answer. Okay, once you've copied that, turn to page 21, and we're going to do some multiplying practice. Okay, number 1, square root of 6 times the square root of 6 equals, okay, aren't they both inside numbers? They're both radicands. So that means you can multiply them together and get 36 on the inside, but then we know the square root of 36 is just 6. And remember, we talked about why it just comes out as a regular 6 without a radical, because when you multiply two things that are identical, you're basically just squaring them because there's 2 of them. And these are inverse operations that cancel out, leaving just the 6. All right, number 3. This time, the radicands do not match, but remember with multiplication, that does not matter. The radicands don't have to match. You can still multiply them. So the square root of 20 times the square root of 25 is the square root of, what is that, 500? You have 500. Okay, so we're done multiplying, and now we have to simplify. What are some numbers that multiply to give you 500? Well, what did we just do to get the 500? 20 and 25, right? Okay, 20 breaks down into what two numbers? 5 and 4. 25 breaks down into 5 and 5. And then the 4 will break down once more into a set of 2's. And then you can bring down all the 5's because they're prime. Okay, so now we circle any sets that we have, and we have a set of 2's and a set of 5's. The only thing not circled was this 5, so it gets to go back inside the radical. And now of the sets, you kill one of each and kick out one of each, making what on the outside? 10. And then that's the final answer. And just like always, if you type in the square root of 20 times the square root of 25, look at the decimal, and then you type in 10 square roots of 5, it should be the exact same decimal. All right, number 5. The square root of 6 times the square root of 12. They're both inside numbers, so they're going to stay inside, but what's 6 times 12? 72. Now we're ready to simplify. What are numbers that multiply to make 72? 6 and 12. There's other options, but those are the most obvious ones. And then 6 breaks down into 2 and 3. 12 breaks down into 3 and 4. And then these are all primes, so they just drop. And then 4 will break down once more into another set of 2's. Okay, now you circle any sets you have. Anything not circled gets to go back under the radical. Kill, kill, kick out, putting what on the outside? 6. Okay, everybody got it copied? All right, let's look at number 7. Square root of 10 times the square root of 5 equals the square root of 50. Okay, which can be simplified. What numbers multiply to make 50? 10 and 5, or 25 and 2. Okay, 10 breaks down into 2 and 5, and then 5 just drops. So now that they're all prime, you circle any sets that you have, put whatever is not circled back under the radical, and then kill and kick out, and you get that. Okay, number 9. What is the square root of 10 times the square root of 8? Square root of 80. Okay, which can be simplified. What numbers multiply to make 80? 10 times 8. And then 10 will break down into 5 and 2. 8 will break down into 4 and 2. And then 4 will break down once more into 2 and 2. And then drop down all your numbers to the same level, so it makes it easy to identify pairs and circle them. We have a pair of 2's and another pair of 2's, putting the 5 back in because it wasn't circled. And then one of each gets killed, one of each gets kicked out, making what on the outside? 4, right. All right, number 11. This time we actually have something on the outside. What is this on the outside? A -1, right? And there's also an understood 1 over here, but until now, it hasn't mattered that there's understood 1s out there because a positive 1 doesn't have to be written. But now that a 1 times a -1 makes a -1 on the outside, it does matter. And then 5 times 15 makes 75. Okay, now we factor tree it. What are numbers that multiply to make 75? 5 and 15, or you could use 25 and 3. 5 is prime, so it just drops. 15 breaks down into a 5 and a 3. Now they're all prime, so we're ready to circle the 5s, kill 1, kick 1 out, and put the 3 back in. And then is that the final answer? No, why not? What have I not done? Right, this -1 will now multiply by that 5, making it a -5. All right, number 13. I'm going to show you a different way to do 13. Not that you have to. You can do it the way we've been doing it, but I'm just going to show you that this can be done if you ever see it. 20, like 10 can't be simplified because if you try to factor tree it, it's just a 2 and a 5. There's nothing to circle, right? But 20 can be simplified. 5 times 4, which is 5 times 2 times 2. Circle, kill, kick out, put the 5 back inside. Now you have 1 square roots of 10 times 2 square roots of 5, which is 2 square roots of 50. But then you'd still have to simplify that. So really, it's just as much work as from the beginning doing the square root of 200. Okay, no matter which one you simplify, it's really still the same amount of work. This one might actually be less. Okay, so, but I'm just showing you, if you ever see anybody simplify first, you can do that. But sometimes it may save you time, sometimes it may not. Okay, so square root of 200. What numbers multiply to 200? 10 and 20. And then 10 is a 5 and a 2. 20 is a 5 and a 4. And then 4 will break down once more into a set of 2's and then bring down all the primes. Okay, now we're ready to circle any pairs that we have. Now, even though these are not side by side, remember, it's still a pair of 5s, so you still circle them. They just tried to scoot apart really quick before the dad came in. The only thing not circled was the 2, so he gets to go back inside the house. Of the circled ones, 1 gets killed, and 1 gets kicked out, putting what on the outside? 10. All right, number 15. Okay, this time we have outside numbers. So when we multiply them together, what do they become? -8. And then square roots of, what's 15 times 20? 300, I think. Is it 300? Okay, so now we're ready to simplify that 300. What numbers multiply to give you a 300? Right. 15 breaks down into a 3 and a 5. 20 breaks down into a 5 and a 4. 4 breaks down into a 2 times 2. And then we drop everything down to the same level. Now we circle any pairs. We have 2 sets of 5, 2 sets of 2's. The only thing not circled was this 3. Kill 1 of each, kick 1 of each out, putting what on the outside? 10. But then don't forget about this negative 8 that will make the final answer right, negative 80 square roots of 3. All right, number 17. Does everybody have that one copied? All right, number 17. When you multiply those together, what does it become? (25) square roots of 24. Now we factor tree the 24. What are numbers that multiply to make 24? Right, or you could use 2 and 12, or 8 and 3. Okay, what are numbers that multiply to make 6? Right, numbers that multiply to make 4? 2 and 2. Now we circle any pairs that we have. Anything not circled gets to go back inside the house, and then since there's 2 of them, they multiply together inside to make 6. Kill one of the pairs, kick one out. But then the final answer would actually become 50, right? Because that 25 times 2 will make a 50 on the outside. Okay, number 19. When you multiply those 2 radicals together, what does it become? What square roots of what? What's on the outside? 15 square roots of 45. Okay, now we factor tree it. What numbers multiply to give you 45? Okay. And then 5's prime, so it just drops. 9 becomes 3 times 3. Then you circle your pairs. 5 didn't get circled, so it goes back in. Of the 3's, 1 gets killed, 1 gets kicked out. But then it will join the person that was already kicked out to make what on the outside? 45 square roots of 5. Okay, we still have 6 minutes, so you can get started on this now, but your homework is every other even. So what I mean by that is like 2, skip 4, 6, skip 8, 10, skip 12, 14, skip 16, and then 18. Okay, you can get started on those problems now, though, because we still have 6 minutes.